So up to now we have discussed the different instruction based on their lengths. That means 3 instruction length, 2 instruction length, 2 address instruction length, 1 address instruction length, 0 address instruction length. And also we have seen how an arithmetic expression can be evaluated with the help of this different type of instruction length. Okay, and we have written a small program of different instruction length. That means for the 3 address instruction length instruction we have written a program. For the 2 address instruction we have also written a program and execute the same arithmetic expression. Okay, now today we will discuss continue of the previous class and discuss the different addressing mode of computer. Now the ALU, arithmetic logic unit of the CPU. Okay, the arithmetic logic unit of the CPU, and this is here ALU, and execute the instruction dictated by the opcode field of the instruction. That means in an instruction, I have already said any kind of instruction. Suppose this is your instruction, add R1 comma R2. So this is your opcode and this is your operand. Okay, so depending of the opcode field of the instruction are executed by the ALU. The different way in which the location of the operand, this is the operand, and the different ways the location of the operand is specified, that is known as addressing mode. Okay, so a computer uses various addressing mode. Now what are the advantages of different addressing mode? Computers use different addressing mode for the two different purposes. First one is it gives programming versatility or flexibility to the programmer with respect to number of instruction and execution time by providing various addressing mode. So it gives programmer a flexibility or the versatility. And next, second advantage is that to reduce the length of the instruction or the size of the program, because these two parameters are associated with the capacity of the memory. So if we use the difference addressing mode, we can change the length of the instruction or the size of, as the length of the instruction is reduced or enhanced, the size of the program is also reduced or enhanced. And size of the program is also associated with the memory, and memory is a vital criteria for the computer. So if we can reduce or enhance the instruction size, then or the program size, then we can also affect the memory of the computer. Now first addressing mode we want to discuss. This is the different type of addressing mode. You will know one by one. That means implied addressing mode, immediate addressing mode, register addressing mode, register indirect addressing mode, auto increment, auto decrement, direct address mode, indirect address mode, relative address mode, index addressing mode, base register addressing mode. Okay, so these are the different type of addressing modes available for a machine. Okay, so first one is your implied or inherent addressing mode. So in this mode of operation are specified, actually in this mode of addressing mode, the operands are indicated implicitly by the instruction. The accumulator register is generally used. The accumulator register, here we use only the accumulator register. Okay, I have already specified in the previous lecture that the accumulator is a special kind of register defined in a machine or the microprocessor. Okay, so all the operations related to the accumulator that are defined in implied mode of addressing mode. Okay, so here suppose the command CMA, this is only associated with the command, no operand is specified. This is your opcode. I have said that for an instruction this is opcode, and if any after that anything is defined, that is operand. So in this implied mode of addressing mode, there is no operand is specified. So we are only instruction, and this instruction is performed on the accumulator only. So whatever the function of the instruction, that is performed on the accumulator register. Okay, so here CMA means complement accumulator. So whatever value of the accumulator, suppose the value of the accumulator is 101, so it is complemented, that means 0 1 0. So that is the function of this implied mode of addressing mode. There is no foremost criteria for this implied mode of addressing mode is that there is no operand is specified in this mode of addressing mode. Okay, only the opcode is specified and all of the operation is performed on the accumulator. That is the implied mode of addressing mode. Next one is your immediate addressing mode. So in this mode the operand is mentioned explicitly in the instruction. In the other words, the immediate mode instruction contains an operand value rather than address of it or the address field. To initiate a register to a constant value, this mode of instruction is useful. So here operand equal to address field. Suppose this is your for any kind of instruction, this is your opcode. Any instruction, I have already said that this any instruction, this is your opcode, this is your operand. Okay, so suppose data needed by the processor is contained in the instruction. That means we have here specified the raw data. That means at 5. At 5 means we have already defined the data 5, not any kind of address or the indirect mode of address like that. So here we want to add the content of the accumulator with the 5 and obviously store the result in the accumulator. So that is the immediate addressing mode. Okay. Also the MVI, suppose you want to move the data, so MVI A comma 06. Okay, so here we want to load the accumulator with the data 6. So that is the immediate addressing mode. Whatever data we want to process, that must be specified in this mode of addressing mode immediately. That means this data has to be loaded in the accumulator, so that has to be specified in the instruction immediately. No indirect mode is tolerated here. Okay, next is your register addressing mode. Register or the direct mode of addressing. So in this mode, processor register hold the operands. In the other words, the address field is now the register field, which contains the operand required for the instruction. You can see in the figure also the address field is now the register field which contains the operand required for the instruction. I have already said that a particular register is selected from a register field of the instruction. In the instruction, out of 2 to the power k register in the CPU, one register is selected using k bit field. This mode is useful for long programming, storing the immediate result in the register rather than in the memory. This will result in fast execution since register accessing is much faster than the memory accessing. So here the main thing is, here this is your opcode, this is your address field or the operand field. In the operand field, that means in any kind of machine, suppose there is 8085 processor. In the 8085 processor, all of you know that there is register residing in 8085 and this register is accumulator, also B, C, D, E, H, L. This is the internal register of the 8085 microprocessor, and this is different in different machine. Okay, so in this type of addressing mode, the operand is rather than immediate data or the address, it is directly the register. Okay, so all of the program execution, in a long program execution where we want to store the intermediate result in the register, where accessing of the data is much faster rather than storing into the memory, because if you want to store it into the memory, then accessing the data will be much slower. So that's why we want to store the result into the intermediate register where we want to access the data much faster. So here the main theme is that this is your opcode and this is your operand. In the operand we want to provide the operand in terms of internal register of the machine. That is the main theme here. Rather than memory or the immediate data, we want to store here we want to specify the operand in terms of internal register of the machine. The instruction, a sample instruction is, suppose this is your instruction add r1 comma r2. So here r1 or r2 are two internal register of any machine. So r1 and r2 are added and result will be stored in, suppose, r1. Okay, so that is, you can see that here it is provided the register, not the any immediate value as discussed in the immediate addressing mode. Here raw data is provided. Okay, and here the not the raw data but the registered data is provided. Next, register indirect addressing mode. So in this mode of instruction, the specified an address of the CPU register that holds the address of the operand in the memory. In the other words, the address field is register which contains the memory address of the operand. This mode is very useful for rapid access of main memory location such as array. So here the thing is that this is your opcode field, this is your operand field. In the register direct addressing mode, the register value, suppose this is your register value is specified in the direct register addressing mode. So this r1 data, whatever may be the data of the r1, that is used for this instruction. Okay, but in the register indirect addressing mode, if we want to specify, this is your opcode, this is your operand, and this operand, suppose this is your operand r1, these operands hold the address, and within that address the value is accessible. Suppose this r1 contains 5000, so processor actually goes 5000 location, and within that location if the data is 05, then that data has to be accessed. So it is useful for accessing the main memory rather than direct data. So it is the indirect, you can see this is the indirect. Actually it is implicitly indirect, because whatever may be the operand is defined, that operand value is not used for the instruction. This operand value holding some address of the main memory, and the main memory, whatever the content of the main memory, this is the r1 contains 5000, so 5000 is the address, and within the 5000 suppose 05 is residing, so 05 is used for the instruction indirectly, not directly. But in the case of the direct addressing mode, we are here using opcode and here using operand. This operand value, the operand value directly defined. That is not in the case. This is the immediate addressing mode. Directly value is defined. Okay. And in the register direct addressing mode, we are defining the register, and this register, whatever may be the value of the register, that is useful in the instruction. But in the case of the register indirect, whatever may be the value of this, that is defined, that is holding some value, that value is used in the instruction. That is the register indirect addressing mode. Okay. Auto increment or the auto decrement. This is similar to the register indirect mode, except that register is incremented or decremented after or before its value is accessed to memory. That means auto increment a equal to 400. R1 is incremented to 401 after the execution. Okay. Auto decrement R1, it is decremented prior to the execution. So whatever may be the value of, suppose this is your opcode, this is your operand, whatever register value is storing, suppose this is 400, and before execution, that means R1 is incremented. Suppose after the execution of the program, R1 is incremented to 401. Whatever may be the value is storing, it is storing into the 401. Okay. Relative addressing mode. In this mode, the effective address is obtained by adding the content of the program counter register with the address part of the instruction. The instruction specified the memory address of the operand as relative position of the current instruction address. Generally, this mode is used to specify the branch address in the branch instructions, provided the branch address is nearer to the instruction. For example, suppose the offset, suppose this is here in this case of addressing mode, content of the program counter, you can see mindedly that the program content of the program counter is added to the address part of the instruction obtained in the effective address. So this is your opcode. I have said already that this is your opcode any instruction, and this is your operand of the address field. So the address field, whatever value whatever may be the value of the program counter, what is program counter, this is your stack. So program counter is actually pointing to the not a stack, it is actually whatever the you have written a program. So program counter actually pointing to the next instruction to be faced into the memory. So program counter, you just see whatever the definition of the program counter. So in this addressing mode, the program counter value is added with this offset value, and final result is used for the addressing. Okay, so here we are defining an offset value, and here our program counter is already defined in the program, so that value is added with that, and next that location has to be accessed in the main memory. Okay, index addressing mode. In this mode, the content of an index register is added to the address field, address part of the instruction to obtain the effective address. Index register, here the in the index register is defined. I have defining it again. In this mode, the effective address is determined determined by adding the content of the index register. Index register is actually defining by this. Okay, with the address part of the instruction. This mode is useful for accessing operand array. The address part of the instruction gives the starting address of the operand array in the memory. The index register is specified in CPU register that contains the index value of the operand. The index value of the operand is distance between the starting address of the operand. Any operand in the array can be accessed with the same instruction provided that index register contains the correct index value. For example, an operand array starts on a memory address 1000. An operand array starts on a memory address 1000 and assume that the index register contains value 002. Now consider the instruction LDA 1000. Okay, so the effective address is 1000 plus 2, that means 1002. That is the part of the index register. That means in the case of the relative addressing mode, here the content of the program counter with the address field is added, and finally that content is memory is to be accessed. Here suppose a stack of operand is defined with different memory location. Suppose this is 1000, this is 1001, this is 1002. Different operand is defined in that location. Okay, so here the opcode and the address field, within the address field, suppose this is 20, the index register is starting from 1000, so 1000 plus 20, so whatever may be the value of 1020, that operand has to be accessed in this mode of addressing. Okay, you can see that the 1020, whatever may be the value of operand, that is accessed. The effective address is 1000 plus 20, 1020, that is defined in different machine. And first you have to define the where the operand value is storing with the different address, starting address and the ending address. Okay, and you just subtract the ending address with the starting address to get this value of the index register, and then accordingly you can access this kind of instruction to get the different operand value. Next is your base register addressing mode. In this mode is for relocation of the program in the memory, relocation technique for moving the program of data segment from one part of memory to another part of memory. Relocation is an important feature of multi-programming system. In this mode, again the effective address is specified, but the content of the base register, here it is defined, the base register is added to the address part of the instruction to obtain the effective address. This mode is similar to the index addressing mode, but the exception is that the way they are used. A base register holds the starting address of the memory array of operands, and the address part instruction give the displacement of the offset relative to the starting address, base register addressing mode. has an advantage of index addressing mode with respect to the size of the instruction, because the size of the instruction is the first case smaller than of the second case. It is very much similar to the index addressing mode, where the memory is defined and the different operand is defined in different location. So you have to define the index register. In that case, here you have to define the base address register, and whatever providing the address, that address is added with the base register, and final address is effective address is generated, and that location has to be accessed with the help of this addressing mode. Okay, that is the main theme of this addressing mode. Thank you.